Sea cargo containers often contain hazardous levels of toxic gases and vapors which are dangerous to the people working in close proximity to these containers, such as inspectors and unloading personnel. These gases are either fumigants or are arising from the off-gassing from the packaging materials and/or the cargo itself. After fumigation, the containers should be labeled with proper warning signs so they are ventilated before opening. However, very often the containers are not correctly labeled, which increases the risk of serious accidents. Usually, this warning sign is the first and perhaps the only message the worker receives that suggests the container's atmosphere could be hazardous. Riedke, a Dutch firm of health and safety consultants, employs portable battery-powered Gasmet FTIR analyzers for measuring toxic fumigant gases in containers. The Gasmet model DX4040 gas analyzer is operated by a laptop which runs the Gasmet Pro software, providing the simultaneous measurement of up to 50 gases. In this video, the basic screening procedure, whether the container needs to be ventilated or not, is presented. The Hanjin container by the Hanjin Shipping Company was used for the demonstrations. The first demonstration was made with a chemical called alpha-pinene. A few droplets of it were added to a white cloth, after which the container was closed and sealed with a standard shipping seal. The sample probe needs to be robust enough and preferably consist of a water trap and a dust filter and a long metal sonde in order to avoid water or dust getting inside the analyzer. The gas measurement certificate is always required and records the container details, including the seal identification, container number, and the gas measurement details. In the gas measurement certificate, there is a list of compounds to be measured along with the stated analysis technology. Later, the measurement concentrations are also documented. A handheld device for oxygen measurement is often used in order to see if the oxygen levels have dramatically decreased, indicating the presence of oxygen-consuming chemical reactions. After checking with a handheld oxygen device, the container was measured using the Gasmet DX4040 multi-gas analyzer. The continuous measurement was started with a measurement interval of 60 seconds. The starting concentration for alpha-pinene was 22.5 ppm.
No extra peaks are coming, so I can go back to the original complete. And then, so this is water, COT, and only here in this area, so nothing else to expect. We have 70.49.
The reliability of the analysis can be checked by comparing the measured sample spectrum to a reference gas spectrum. In this case, they show complete overlap, and one can be sure that the analysis results are reliable. The red bar after the concentration unit is caused by the user-defined concentration alarm, which can be manually set to occupational exposure limit values. The red bar alarm gives an immediate and clear indication to the user that the container needs to be ventilated. Very often it is impossible to say which gases are present for sure, and the measurer in charge can only speculate what gases may be present based on the goods inside the container. For identifying gases in an unknown sample, the operator can utilize the Gasmet Pro software. This advanced library search tool provides suggestions of which toxic gases may be present in an unknown sample spectrum, based on a statistical probability function or fit rate, along with the estimation of the gas concentration. Water, carbon dioxide and methane were in the analysis because one can be sure that these gases are almost always present inside a container. Then, the library search routine was started, the green progress bar indicating the search being processed. In a few seconds, results are shown in a separate window, alpha-pinene having the best fit, after which it was added to the analysis by selecting it from the gas library. A second routine was performed indicating that duodecane is also present, so it was added to the analysis. The third search showed no other compounds were found, so the final gas concentrations were documented on the measurement certificate. The second demonstration was made with chemicals beta-pinene and 1,2-dichloroethane, and the measurement procedure followed the same protocol as the first demonstration. This time, the container was sealed with a special certified seal. Again, the container was measured with a handheld detector for oxygen and VOC concentrations, after which it was analyzed by a Gasmet Model 4040 multi-gas analyzer. Low residual values indicated that no other components should be present. The concentration of 1,2-dichloroethane was also checked with 2 different detector tubes, which is very often the case if the concentration is close to the exposure limit value, such as the TLV. Finally, after measurements, the container is declared safe to enter, or it is reported unsafe, which means that it needs to be degassed and ventilated again before opening. Serious accidents can be avoided by using reliable and accurate instruments. It is necessary to be able to identify unknowns, as one can never be sure what gases are present. Measuring a large number of gases simultaneously lowers the time required for container inspection, ensures no false negatives, and increases the number of containers examined per day. FTIR technology represents a good balance of sensitivity and the ability to cope with a complex gas matrix, unlike any other portable gas analyzer. Gasmet has developed a portable and fast, laboratory-grade, field rugged device for use by port personnel working in close proximity to shipping containers. If you have any questions concerning our analyzer, application, or the software, please contact Gasmet or visit us at our website www.gasmet.com, and don't forget to follow us on LinkedIn.